Hello everyone, my name is Rishikesh Sutar and today I'll be presenting for Deep Learning ISC 2. So the topic of my presentation is Introduction to Deep Learning, Biological Neuron versus Artificial Neuron and Deep Learning versus Machine Learning. So let's get into it. First of all, we'll discuss the introduction. The question arises, why deep learning, right? So in today's data, there are a lot of platforms which are digitalized. So with that digitalization, we get a numerous or humongous amount of data. Yes, so the data is known as the gold of today, right? Or the oil of today. So we can utilize this data to come up with multiple solutions, and we can utilize this data for better decision making. So that would be the reason. And also for this, why deep learning as a technical perspective, that traditional algorithms lack that understanding of complex patterns, which is needed in a real world data, because the data we get in real world is unstructured data, and there is lot of complex patterns which are there and lot of relationships that which are there, right? So then why deep learning is like good at this, because deep learning uses a similar kind of like a workflow which mimics the human brain. So it works like a human brain, and I mean it is very useful to like better decision making from a huge amount of data. So, for example, there in image recognition systems, the CNN models are trained to recognize the faces of people, which will be useful in order to deal with cybersecurity issues. So, the example description is like instead of manually defining edges or colors, the model learns from the data automatically. So that was the introduction. Next, let's get into the concept, right? So, what is deep learning? So deep learning is nothing but a subset of machine learning which uses multiple neural networks. By neural network, I mean the like it resembles the structure of our neurons in our brain. So like our neurons in our brain are interconnected, and they are they are used to share data among themselves. Same thing with artificial neural networks. They also are very dense connected neurons, artificial neurons, and they are connected together to share and transfer data. So yeah, I mean, and again, it learns the hierarchical representation from raw data, and it is inspired by how neurons work in a brain. Okay, so this might be useful for recognition of speech, and that can be done using again neural networks. So example would be like models like RNN and CNN help machine understand language or vision similar to humans. So like the machines can have that capability of humans, which will enable them to understand human language and also see like humans too. So like working mechanism would be, next part is working mechanism. In working mechanism, how it works. So there are like multiple layers present in a neural network or a deep learning network. First one is input layer, which takes the input in form of multiple multimodal data. Then there is a layer of neurons, which applies the weights, biases, and activation, which transforms the data and learns the complex patterns from the data. And then, in order to train the model, there are multiple training parameters which are used, which helps in training of model. So the example is neurons versus biological neurons. So in artificial neurons, this is the working mechanism which we follow, which involves input layer, hidden layers, and output layer. So the example is like biological neuron transmits electrical impulses, while artificial neuron computes weighted sums and activations. So that was a working mechanism. Then what would be the challenges that we face while using these deep learning networks? Even though these networks are very capable in themselves, but in order to train these like very capable neural networks or deep learning networks, we need a humongous amount of data, a large amount of data. So it's not possible that for every use case you'll have a large database which where the data will be stored, right? So will that would be the challenge that we face in deep learning domain right now. That in order to train these heavy models, we need lots of data. So gathering the data is a very difficult task for everyday small enterprise users. So and after there is again a challenge of acting as a black box. So uh, even though the model gives us responses to our queries, but the model fails to give the explanation by how the model came up with that decision or a response, right? So that just, I mean, that becomes a response mechanism without much understanding. So that is one like limitation. Again, risk of overfitting. So when we train these complex model on small data sets, the model, instead of learning patterns, just mimics or remembers all of the data. And when we get these models to work on real-time validation data set, these models fail to perform. So that is the issue of overfitting. So the example is that when the data is limited, model accuracy drops drastically. And unlike humans, deep learning models need extensive training to generalize. So that is the limitation. Now we'll come to the summary of it. What we discussed so far. So again, the key takeaways would be deep learning is inspired by biological neurons, but implemented mathematically. So even though the architecture follows a similar structure of neurons, but the computation behind is implemented by mathematical models only, and then it surpasses traditional ML in performance on complex data. So for handling complex data, these deep learning models are very much effective rather than our traditional ML models. And despite high accuracy, interpretability and resource needs remains challenges, right? So again, even though these models have higher accuracy and good responses, the need of having that humongous amount of data, large amount of data, still remains viable. So then an example is like AI applications like ChatGPT, self-driving cars, and medical imaging rely on deep learning foundations. And the example description is that the technology continues evolving towards more explainable and efficient systems. Like I told you about the black box problem. Now we are putting our efforts to counter that black box problem. And with the time progress, these deep learning systems will evolve and will be able to produce very good outputs based on very high context and very good real world data. So that was all from my side. Thank you.